Okay.
Okay.
Okay, we'd like to welcome everybody to our session, Are You Listening? JavaFX Binding Techniques for Rich Client UIs. My name is Paul Anderson. This is Gail Anderson, and we are with the Anderson Software Group. And over to the left is Geertjan Wielenga from NetBeans. So who are we? Gail and I are Java developers, and when we're not writing a lot of our own code, we're putting together courses and teaching other Java developers a lot of tips and techniques that are useful. We have courses in Java 8 and JavaFX, and our company is based in the US. We are also the authors of the textbook JavaFX Rich Client Programming on the NetBeans Platform. I'm the author of 2 live lesson videos from Pearson Education, one on JavaFX programming and one on Java reflection. And Geertjan is the author of Beginning NetBeans IDE. And we brought our books along here, so we're going to be giving those away at the end of this talk to the most interesting question that people come up with. So you can be thinking of that as we go along. All right, now what's our game plan? What's our agenda for today? Okay, we've got a couple of neat demo programs to show you. The first one is going to be a standalone JavaFX program that will teach you a lot of techniques in JavaFX that will help you design UIs more efficiently and more effectively. We'll go through the demo program at the beginning. Gail will demonstrate it and I'll walk you through it. And there'll be a lot of simple things in the UI that you'll see, but I think that you'll be interested to see how we're doing these techniques, and particularly when we come back and go through the code and show you JavaFX properties for your model data, the listening and binding techniques that we're using, how you use observable lists in JavaFX to manage your data. And also, the program is all written in Java 8, so you'll get a chance to see a lot of techniques with lambdas and streams. And in fact, we'll show you how to use JavaFX binding with streams in Java 8. At that point, we'll turn it over to Geertjan, and he will be talking about the NetBeans IDE and the NetBeans Platform. And the NetBeans Platform is a swing-based framework, so it'll come back to me, and then Gail and I will show you our second demo program, which will be a port of the standalone JavaFX program to the NetBeans Platform, and then you get a chance to see how to integrate JavaFX and Swing together. At the end of the session, we'll wrap everything up. We'll tell you where you can get the source code. It's downloadable from our website, and you'll probably want to look at our programs to learn a little bit more about these techniques. And then we will have question and answers at the end with 2 book giveaways, as I said. And I'm planning on having about 5 minutes or so for questions from the audience, but you're also welcome to use the hashtag on Twitter, JavaFX Binding, and you can also post some questions up there, and if we don't have time to get to those, we'll answer them later. Okay, so let's get started. Gail's going to switch over to NetBeans now, and we're going to bring up our first demo program. And we already have it open, so all she has to do is run it. Okay, now what you're looking at here is a BP monitor application where BP stands for blood pressure. And one could imagine a program like this being a part of a larger medical application, or it could be a standalone desktop program that helps a person determine their blood pressure data over a range of dates. If you went to Johan Voss's JavaFX on mobile talk yesterday, you could easily see that we could port this program over to mobile, which we plan on doing in the future. Now, the UI that you're looking at here was created with Gluon's Scene Builder tool, and that's a tool that allows you to drag and drop JavaFX components to a screen, and then you can manipulate all those, and then the Scene Builder tool from Gluon creates FXML code, not Java code, but FXML code that helps you reduce the number of Java instructions that you have to use, and then we implemented a controller class in Java to configure those components. As I said, we'll go through the demo program here, and then we'll show you all the techniques in the actual code. Now, on the UI, it's divided up into 4 sections. On the top left, you can see some controls that will give you a blood pressure reading, and including dates and times. And then underneath that, we have a JavaFX table view that shows you a range of blood pressure readings that are sorted, okay, by date and time, and also filtered, right, over a range of dates. And we'll be showing you how we're doing those sorting and filtering in JavaFX later on. On the right side of the UI, we're visualizing the data for the user by using JavaFX charts. Okay, we have some buttons at the top that will show you, and then we have a line chart in the middle. And this is the components of a blood pressure reading, which is systolic, that you see in the table, a systolic reading, and then a diastolic reading and a pulse reading. And then we have colors for those, the red line for the systolic, the orange for the diastolic, and then the green for the pulse. Underneath the line chart, we have a bar chart that puts out summary statistics. Okay, so let's interact with the UI now and start showing you some of the things that you can do with this and how we're going to do this in JavaFX. Okay, so the first thing Gail's going to do is show you some mouse movements. If she puts the mouse over any of the lines, you can see that we are putting she's able to see the numbers representing the values that are there. And this is very easy to do in JavaFX to be able to pop those numbers up, and is a good experience for the user. She can also go down below and put the mouse over any of the bars in the bar chart, and those represent, on the left, the maximum values for each one of the 3 series. The middle represents the averages of those those 3 readings, and on the right, the minimum values. Okay, let's go back up now and start clicking on some buttons, and this will change the range. And when she does that, you'll see the charts immediately react and display new ranges of data. This is all very easy to do in JavaFX when you organize it all with observable lists and the binding techniques that we're going to show you. She can go to the last button to get the last range. She can go to the first button. And Gail can also go up to the date picker and pick a new starting date. And once again, the charts and the table immediately react with each one of those things that she does. Okay, now let's go in and select a reading. And several things happen here in the UI. First of all, we put some drop shadows on the reading. That's very easy to do in JavaFX. We also select the table, the row in the table, so the user knows about that. And then we populate the controls up above with the blood pressure reading. Gail can also go into the table, and she can select any reading from the table, or she can go back over to the line chart and access any of those blood pressure readings. I'll notice that the delete button is also enabled, and then if she clicks anywhere in the background in the line chart, then all of those effects go away. Okay, so let's select a reading now and change one of the blood pressure readings. So she selects that one, and then she'll go over to the left and she'll put in a larger number. And notice that the update button was immediately enabled when she did that. Now when she clicks on the update button, you'll see the charts immediately react, as well as the table being updated. In fact, if she goes over to the line chart there, you'll see the new number at the top there, and you'll see the new maximum for that reading down below, and then the new number that she put in over in the row in the table view. Now let's show you how to delete a blood pressure reading. We already have one that's selected, and the delete button is activated as well. So when Gail clicks on that delete button, oh, what happened?
It's okay. We'll do
Oh, okay. What happens is it all goes away, right?
I'm assuming it'll come back.
Yeah, that's strange. Okay. So when you click on the OK button there for the confirmation dialog, then what happens is that the reading was deleted. And when that happens, the table automatically is deleted for that, and it's automatically resorted and refiltered if it has to. Now let's go in and create a new blood pressure reading. And so Gail will go up, first of all, and select a date that's going to be in the same range that's in the table. And then she'll populate these text fields with a blood pressure reading. And notice that as soon as she puts in something in the pulse field, you'll see the add button enabled. And then if she backspaces on any of that, you'll see the add button disabled. This is one line of code in JavaFX with a bind, and we'll be showing you that very soon.
So I think the same thing will probably happen.
Yeah, so the same thing's going to happen now when, it wants to move the window over, which doesn't happen on a real desktop. Again, a confirmation dialog, and then when she clicks it. Now, the thing that you didn't see was, I want you to look up above the bar chart. The number of readings is constantly being updated to the correct number that you're seeing at all times. We also have that in one bind statement as well. So as you add readings, delete readings, or so forth, that title is always being updated in just one line of code. Okay, so let's terminate the application now. And before we go back to the notes, Gail's going to bring up the FXML code just so you can look at that. Remember, I mentioned that when we designed the UI, we used the scene builder tool, right, to drag and drop the components, and then that tool generates FXML code. And this is what you're looking at right now. This saves you a lot of time when you're coding because you don't have to instantiate controls and call setters to configure them, because the FXML layout will all do that for you. You can also go into the FXML and edit it yourself, and it's a very, very nice way to design UIs like this. Okay, let's go back to the notes and start looking at some code. Okay, so the first thing that we want to talk about are JavaFX properties and why you want to use them in your model data. So we'll begin by telling you, what is a JavaFX property and why would you want to use it? A property in JavaFX wraps your data so that it's observable, which means that registered listeners can be notified when a property updates. This is a very powerful concept in JavaFX because when you have a property, you can attach a listener to it, and you can also call these binding methods that we're going to show you in a little bit. JavaFX supports properties for the readable and writable, also properties that are read-only, and also properties that are immutable and cannot be changed. Okay, Gail's going to go back into the code now, and we're going to show you the properties that we're using in this demo program. Okay, there we have 4 properties, actually 5, but I'll show you these 4 first. What you see here, we have an object property, which is generic. And by the way, we're using the Java 8 local date and time class for the dates and times that you see in the program. And then we have 3 integer properties that handle the systolic, diastolic, and pulse data for the blood pressure reading. Down below in the constructor, you can see that we're newing the simple object property and simple integer property. We're passing the object that the properties belong to, and then we're using static strings, which is a nice part of the property constructor, because then we can use those static strings to populate the table view with the cell factories that we're using. We have another property too that's called OK to add, and you'll remember from the demo program that there are times when you can add a property if nothing else is selected, so we maintain that property ourselves. Now, if Gail scrolls down just really quickly on this rest of this file, you'll see the familiar getters and setters that you all know. And notice that they're calling get and set to get the wrapped values back or to change them. But the other thing you want to notice is that there are these new things in JavaFX beans called property getters. And these you need to have because those are what you'll be calling to attach listeners and to do binding expressions. Okay. Yep.
Hello? And I wanted to add that JavaFX properties have naming conventions just like the traditional Java Beans property. And the naming conventions you see here with the property getters being the name of the property with the word property appended to it. So it's important to use these naming conventions because a lot of tools assume that, and other people using your code will want to see those same naming conventions.
Okay, so let's go back to the notes and look at the next topic on the agenda. Okay, now this is really what most of the talk is about, is to show you how to use listeners and binding techniques with these properties that we have defined. All right, let's start with listeners. Okay, so what's a listener? A listener is something you can attach to a property so that you can monitor changes when that property gets updated. You can add a listener or remove listeners dynamically in your program, and a listener will be notified when a property that it's attached to updates or changes at some point. There are several listeners that you can use in JavaFX. We'll show you these two right now. The Invalidation Listener, which is where you get a callback when a value becomes invalid, and a ChangeListener, which you get a different kind of callback when a value updates that gives you access to the old or previous value before the update in addition to the new one. And this can be quite handy in certain situations, as you'll see. Okay, let's go back to the code now, and let's show you some examples of these two listeners that we have in our demo program. I can say one thing if you are familiar with Invalidation Listeners. Invalidation Listener is a functional interface that observes properties for invalidations, and you can implement a invalidation listener with either an anonymous class or a lambda expression, right? Because in Java 8, an invalidation listener is a functional interface, and we'll be using lambdas, of course, throughout this talk. Okay? All right, so there's two invalidation listeners that we have in our program, and this is the first one that you see. This one is added to the controls that you saw in the top left of the UI. And this listener enables the update button if the delete button is also enabled when any of the controls value or text property changes, right? Those were the text fields and the spinner and the combo box and those things. When a reading is selected, the attached invalidation listener is what makes the update button enabled as soon as the user interacts with any of those controls. Note that so the other invalidation listener that we have below is added to the start date, and this one reinvokes that filtered list that I talked about when the start date becomes invalid. And this happens when the user selects a date with either the date picker or any of the range buttons that we showed you. And remember that the table view shows the blood pressure data in the new range, and these changes, as you'll see, will automatically propagate to both the line chart and the bar chart. Now, let's show you the ChangeListener that we have in the program. Now, a ChangeListener is also a generic functional interface, and it observes properties for changes. But a ChangeListener, the difference between a ChangeListener and an invalidation listener is ChangeListeners give you access to the old value as well as the new value. Here is the example of our ChangeListener in the demo program. The listener is added to the table view's selected index property, which changes whenever the user selects a different row in the table. Now, remember that when the user does this, either by selecting a reading in the table view or the line chart, we have to remove the drop shadows. And that means that we'll need to know what the previous reading was, right? So that's why we're using a ChangeListener here. And inside the lambda that you see here, the old value is used to remove the drop shadows in the line chart, and those are the calls to set effect null that you're seeing there. Okay, let's go back to the notes now and talk about what's really interesting in JavaFX, and that is the number of different binding strategies that you have available to you. Okay, here they all are. This is a very rich concept in JavaFX. If you've done a lot of swing programming with UIs, you have to work pretty hard for all this. And in JavaFX, there's a lot of really nice techniques that are available to you that you can use. So here are the 4 binding strategies that I'm going to go over, and we'll be talking about those each one separately. And the first one that I'm going to talk about is unidirectional, and then we'll show you how we're using that in the code, and then we'll show you the examples of each one of these other ones. Okay, let's go back into the code now and show you an example of unidirectional binding. So what's a unidirectional bind? This creates a dependency between a source property and a target property. When the dependent property changes, then the target property updates. Now, unidirectional binding is a one-directional binding, and calling a setter on a property that you have bound, it actually generates a runtime error. You can still call setters on a property that's bound, but you have to unbind it first. Also, an implicit setter is done by the system the first time you call bind to sync the values for both the source and the target properties, so they're always in sync. Okay, Gail's got the example up for unidirectional binding, recall that with the buttons that were up above the line chart allowed you to move forward in the data of range dates or back, and we had a next button and a last button. So when you look at the two bind statements up there, those two statements are keeping those two buttons in sync at all times. Specifically, the disable property of the next button is bound to the disable property of the last button, and we do the same thing with the previous and first buttons. So this keeps the state of those buttons the same in all cases and in all scenarios with just two lines of code. Okay, let's go back to the notes now and talk about bind bidirectional, which is the second strategy that you have in JavaFX. This creates a dependency between one property and another in both directions. Remember, unidirectional binding was only one direction. Here you can have a binding in both ways. And with bidirectional binding, you can call set. It always succeeds with either property. Now, in our demo program, we didn't have an application or a requirement for bidirectional binding, but I put up a little simple example so you could get the idea. And the idea is that you have a label on your form and you have a bean in your model, and you want to always have the states of this label and the bean always be the same. So you set up a bidirectional binding between, you bind the text property of the label in the UI to the word property in a bean. And the behavior is that if the text property updates on the UI, then the model word property updates. And if someone calls a setter in the model to change the word property, then the label will automatically change. And this is all done with one line of code to keep everything in sync between your model and your view, and this makes UI designs much easier to implement. Okay, so now let's talk about Fluent API Binding. The JavaFX designers realized that they could help out a lot of UI designers by giving you libraries that are very, very complete and can allow you to do binding expressions without having to do it yourself. So the Fluent API is a large library of instance methods that you can chain together with the builder pattern. That means you can call them with dots, from left to right. And the names of these methods are very readable, so you'll be surprised on how the clarity of your code will look when you start using the Fluent API binding libraries. The categories are separated out into these, so you have expressions that handle Boolean bindings, number bindings, of course string bindings, and more general object bindings as well. Okay, let's go back into the demo program now and show you a really cool way that we're handling the add button. Remember, I showed you that when Gail put in the text field values and backspace through one of them, the add button was being enabled or disabled. And I said we were doing this in one statement, and there it is right at the top there. So the disable property, the add button, is bound to a binding expression that uses the Fluent API .isEmpty, .or, and .not methods. So what this is specifically doing is it's disabling the add button if the text properties of any of the three blood pressure readings text fields are empty. Okay? The add button is also disabled if it's not okay to add. And remember I told you we had a separate property that said whether it was okay to add or not okay to add. For example, you can't add in our program if a reading is already selected, and that's why we have the .not there on that. But that binding expression handles all the scenarios for whether the add button is enabled or disabled, and we're using the Fluent API in JavaFX to do that. Now the Fluent API, if you go back to the notes, the Fluent API is not the only game in town. There's also an even larger library of factory method bindings that you can use. This is a library of static methods that is invoked with the bindings class, where at least one argument to each one of these methods must be an observable type. Just like the Fluent API, there are several binding categories, in fact more here that you have. They have categories for binding expressions for arithmetics, so you can actually do multiplies and divides and arithmetic, numerics, relational and logical, and of course strings. And then some really neat factory method bindings called creationals that I'll be showing you in a minute that allow you to create bindings on the fly. And then also factory method bindings that work with observable lists and values. Okay, let's go back into the demo and show you some factory method binding techniques. Okay. All right, now remember, above the bar chart, I told you that at all times the number of readings that you're seeing, which is not always the same number depending on how many readings a person put into the data for the blood pressure. We're updating that at all times, no matter how the UI is being interacted with this binding statement. And the stat chart is the bar chart, and we're binding the title property here to a factory binding expression. And specifically, we're using the bindings.concat method here to create a string binding to update the title property in the bar chart. We're also using the binding.size method, which returns the length as a numeric expression for the systolic series. And then we need to convert that to a string using the Fluent API as string method. And what this does is it makes the current number of readings in the line chart always appear correctly above the bar chart. And I don't know if you've noticed, but what I've actually done here is I've shown you an example that combines the static factory method bindings with the Fluent API. So you can actually put that all in one expression like I'm doing here. Okay, the last binding strategy, if we go back to the notes, is called custom binding. And this, of course, is where you just have to do it your own way, right? You know, you've got something complicated to do. It's a lower level technique that is it's a direct extension method where you specifically specify the dependencies and then you override a callback method where you can do anything. I mean, you might have to go update a database or do something complicated, right? And so you typically use custom binding because there's nothing in the bindings class or the Fluent API libraries that's appropriate. And also, you know, the custom binding can often be more flexible and in some cases can give you better performance as well. All right, we'll go back in the notes once again here and show you where we're using custom binding. And then I'm going to show you another way with lambdas to be able to replace the custom binding technique with anonymous classes with a creational binding using with lambdas. Okay, now you might have noticed that we have the, what's commented out here is actually the custom binding technique. So I'll go through that first, and then we'll show you that it can be done with a creational binding as well. Okay, so the custom binding is implemented with an anonymous inner class. So that means that you select a binding abstract type from a list of binding classes, and then you bind the dependencies in the superclass so that if any of those update, then you get a callback for the result in the compute value method that you see here. So it's a little verbose to work with because you have to create the binding first, and then you have to override the method. And notice that the super.bind up there is listing the dependencies for those properties that are changing. And then you get the callback to the compute value. And then what we're doing here is we have the logic in here which determines how to disable the first button in the UI. Now, what's interesting is that instead of doing this with an anonymous class, in Java 8 we have lambdas. So you could do exactly the same thing. And if you scroll up a little bit, they can see that. So what we did here was this is actually the code in the UI that's performing this operation. We don't have time to comment this out and show you that it both works, and you can try that yourself. But up above is the Java 8 way of doing this, which doesn't require an anonymous class and is a bit more concise. Okay, so what you see here is you see a bind call with the bindings.createBoolean binding. Okay, that's the creational binding that is in the factory binding library that I mentioned. And then you use a lambda, right, where the code inside the lambda is exactly the same code that you saw down below in the compute value. And that's it, right? So, with custom binding, you still have the ability to create callbacks and use anonymous classes, but you also now have the option in Java 8 to use the creationals and also the lambdas, as we're doing here.
And I'd like to add that it may not always be possible to convert a custom binding to one of these lambdas, because what's in the compute value for a custom binding can be anything you want as long as you return the proper type. But you may, for example, you may just want to have a print line in there, or you may want, as Paul said, do something more complicated, like make a call to a database or something like that.
Yeah. Okay, let's go back to the notes now and talk about something else in JavaFX that will really help you with your UIs. And this is managing your data with observable lists. Okay, now JavaFX has an observable list class, but it also has a sorted list and filtered list, and we're using all three of these in our UI. All right, now an observable list holds your data and notifies the listeners of any changes. In JavaFX, you can typically create these for arrays, lists, or maps, and you use the static method in the FX collections class to do this. Now, the other ones that are interesting, which we were able to use in our demo application, is the concept of a sorted list. And a sorted list is a generic read-only collection that wraps an observable list and keeps its contents sorted with a comparator that you can specify. Any attempts by you to modify a sorted list, say with adds or deletes, will generate a runtime error, but the sorted list can change internally whenever it resorts or when its wrapped list changes. Now, I mentioned that the table view was filtering the range of data at all times when you're interacting with the UI, so we're using a filtered list in JavaFX to handle that. This is also a generic read-only collection, wrapping an observable list, but it filters its contents with a predicate. And if you know about filtering in Java 8, you know that a predicate is a condition that can be true or false. So specifically, if the predicate for the filtered list is true, then the data in the wrapped list is included in the filtered list for you. Otherwise, it's not. And remember, you don't have to write any of this code. It's doing all this for you, right? And that's the point, and that's why it's cool. Now again, any attempts by you to modify a filtered list with adds or deletes is going to generate runtime errors. However, the filtered list can obviously change internally whenever the predicate is applied or whenever the wrapped list changes. Okay, let's go into our demo program now and show you how we're using observable lists. Okay, the first one at the top is the backing list. This is created with an FX collection dot observable array list method call, and this holds the blood pressure data that you saw. Underneath it is the sorted backing list that's created with a sorted list constructor and wraps the backing list above it. The lambda expression in the constructor defines your compare function, or our compare function, that sorts the data in the blood pressure data. Now the filtered list is created with a filtered list constructor and wraps the sorted backing list that's right above it. Once again, we're using a lambda in the constructor to define the predicate for the filter. Now you'll note that the predicate is initially false, which means that the filtered list will be empty. However, as the program runs and the user interacts with the UI, the filtered list will get populated according to the selected date range or by redefining the predicate. Now, when data is added to the backing list, the sorted list keeps the data in the correct order, all for us. We don't have to worry about that at all. And also, the filtered list will automatically apply the predicate to the new data to see if it's within range or not. Now, the line chart also has 3 observable lists, and this is created by, again, the same static method that we created the other ones with. The first list that you see here is the systolic readings, the second list the diastolic, and the third is the pulse data. And here, each list is a JavaFX XY chart data type with a date string on the x-axis and a reading number on the y for the y-axis. Okay, so now let's move and stay in the code, but now we want to show you that we're using sorted lists for the line chart as well. And here, Gail's bringing those up right now. There they are. Okay, now the line chart has 3 sorted lists that are all created, again, by sorted list constructors. The first argument in the sorted list constructor is the observable list for the blood pressure reading that you're looking at. And the second argument is a lambda expression that defines the compare function to sort the dates in the blood pressure reading. Note that we're using the same custom comparator here for each one of the sorted lists. And specifically, what this comparator does is it converts the string representation to local date and time objects to do the comparisons. And in this way, the line chart keeps its display data sorted by date at all times. And when data is created and added to the line chart's wrapped list, the sorted list keeps the data in the correct order at all times. Okay, now let's go back to the notes and talk about how you can wire these observable lists to your controls in JavaFX. And these are the interactions that we're showing you here. Okay, now recall that the backing list in our program holds the blood pressure data that can be added, removed, or updated. Now the sorted backing list wraps the backing list and resorts with a date comparator, and then the filtered list wraps the sorted backing list and uses a predicate to determine the date ranges. Now what you want to look at here is the call to set items with the table view control. That's the BP table, right? And the filtered list argument makes the blood pressure data sorted and filtered in the table at all times. The table view will automatically update anytime the filtered list changes once this item's property is set. Now likewise, the sorted list for each one of the charts wraps the observable lists with data for each line chart series. And we use a custom comparator there, like we said, for the resorting. Now the call to the call specifically here to yeah, where was that? Oh, yeah, it's where we're, yeah, the set data, that's where it is, the set data right there. That one is going to make the XY charts sorted to the line chart at all times. And just like the table view control, the line chart will update automatically when any of the sorted lists change once this data property is set for each series. Okay, let's go into the notes now and show you another listener that you can use with observable lists. And this one is called a list change listener. Now, what's a list change listener? This is a generic functional interface that notifies you when changes are made to an observable list. And it uses a nested class that will report updates, removals, additions, and permutations anytime that happens to your list. And typically what you do is you iterate through this list with a call to .next, and then you can get the change and update your own specific methods to determine what to do. Okay, Gail's brought up the list change listener now in our demo program. This listener is added to the filtered list that I talked about and keeps the line chart synchronized with the table view data. You can see that we have a while loop here, and we're going through, and if the change was removed, then we remove the blood pressure reading from the chart, and if it was added, then we call a method to add it. You might want to know that this listener can be called with one change or multiple changes, but this is the technique that you use to process that. Okay, let's go back to the notes and show you one more important topic with observable lists. And this is something that isn't discussed a lot out there, but it's really important. It's the notion of extractors, where an extractor in JavaFX is a named property that listens for changes on that property. And extractors can help notify you when the named property updates in an observable list. Now, updates are different from additions and removals. This is why extractors are here, because without an extractor defined, a list change listener will not trigger or notify you when anything is updated in the observable list. And if you need that, then you should use an extractor, and you can implement an extractor with either an anonymous class or a lambda. Now, in the example that we're showing here is defining an extractor with a date property. And that means that if any of the date property values change, the extractor will call the list change listener and it will update the trigger. And this will cause a resort or refilter depending on what happens with the date property. Now, when you use extractors, you can then call the wasUpdated method in your list change listener, and then you can that will make the sorted list resort and the filtered list refilter. Now, you should be aware, with some experience that we have, that extractors can sometimes add additional overhead for your list updates. And it may be more efficient in some cases to remove and add elements instead of tracking them all the time with extractors. Now, in our program, because the filtered list has to propagate to the line chart data, we decided not to use extractors. So we instead do perform updates with removes and adds. And so we don't need to use an extractor to keep the sorted list and the filtered list properly sorted and filtered. However, you might want to remember to use an extractor and consider one if you need to make your lists current when you're applying any updates. Okay, now the last technique that we'll show you in our first program is how you can do binding with streams in Java 8. So Gail will go back to the program one last time here, this first demo program, and we'll show you, a really cool method that we'd used here that we're able to this will give you an example with streams to see the binding techniques again, because we used several of these here in different ways. Okay, now this is a method called setup chart bindings that's called 3 times. Recall that a blood pressure reading has those 3 series, right? And what we have to do is we have to update the bar chart statistics from what you see up in the line chart. Okay, so that's what we're doing here. There are 2 arguments, parameters for this setup chart bindings method. One is called the source list, and the other is a target list, and both of those are observable lists. So what we have to do is we have to do 3 things here. We have to calculate the maximum value for the 3 series. We have to, in each one of those, we have to do the average and we have to do the minimums. So what we decided to do here was we wanted to show you that we could use different binding techniques for each one of those 3. Actually, we're using a listener on the 3rd one. Okay, so let's look at the first bind. This uses custom binding to determine the maximum. The dependency is the source list, and the compute value callback method determines the maximum value. So what we do is we call .stream on the target on the source list, and then we use the map to int method to extract the chart y value from the stream, and then we can just call the max method in the library to return the maximum. And this comes back as a Java 8 optional, and because the source list is empty, there's an or else method that you can call on the optional that will give you a default value, and in this case a 1. Now the second bind has to calculate the average. And here we decided to use one of those creational bindings with the lambda again, so you get to see that one. This one will be a create double binding, whereas before we did a create Boolean binding. In the lambda expression, we're doing the stream again on the source list, and then we call map to int to extract the y values from the stream. And once again, there's a method that will compute the average for you, returning it as an optional, and again we're going to do the or else method to return a default of 1 if the source list is empty. Okay, the last one is calculating the minimums. Here we decided, gee, we don't even have to use binding, we can use an invalidation listener. So we use the same stream technique here to map the y values, determine the optional minimum, and return 1 as a default.
And I just wanted to add that this technique, well, any of these techniques here only work to reflect updates if you use an extractor for the y value property. That's one way you can do it. Or how we do it is when we do an update, we actually do a removal and an add. So you have to do one of those techniques to get this binding to work for simple updates. You don't have to worry on add and removals. That will always go through. But we also want to have new averages, new minimum and maximums on updates. And so you either have to use an extractor or you have to do add and remove for an update.
Okay, so we're done with the first demo program. Do you want to close that one out, or? Yeah, so Gail's going to close that program now, and then we'll go back to the notes and talk about the last topic here, which is JavaFX and Swing integration. And she's going to bring up this second demo program for you now. Yeah, and then go back to the notes. Okay. So we'll go back to the notes now, and let's talk about JavaFX and Swing. Okay, so next slide. All right, now if you have to make JavaFX work with your legacy Swing code, what's the plan? You know, what's the reasonable approach here? Well, there's a really nice Swing component called JFX Panel that you can use. It allows you to easily embed JavaFX content in any of your Swing-based applications. And the reason why this is so nice is because if any input or focus events occur, the JavaFX panel will automatically forward them to the JavaFX scene graph, and then you can receive them on the JavaFX side on the JavaFX application thread. Creating a JFX panel is trivial. You just instantiate it, and as soon as you do, that starts up the JavaFX application thread. And here we just have a simple example of adding a JFX panel component to the middle of a Swing container, say with a border layout. Now, there are some thread issues that you need to be aware of when you're using JavaFX and Swing together. They're both separate UI toolkits, and they both have their own threads. Most of you are familiar with the fact that you must call swing utilities.invokeLater to on the EDT to update any Swing control. So it's very easy to do if you just understand the basic concepts, and that is that if you have to update a Swing component from the JavaFX thread, then you need to do that on the EDT. And since we're in Java 8 now, you can very easily do this with a call to the static invokeLater method in Swing utilities, and then just use a lambda to call your Swing method. Now, you might have to go the other way, which is to update a JavaFX control from the Swing side of your program. And here, you must do that on the separate JavaFX application thread. And fortunately, you know, the UI, the JavaFX designers gave us a complementary way of doing that. It's just a different method, a static method called runLater in the platform class, and you use a lambda once again to call the JavaFX method, which will be updated on the application thread. Okay, at this point now, I'm going to turn it over to Geertjan, and he's going to talk about NetBeans IDE and the NetBeans Platform.
So one thing you could do when you're creating Swing applications and together with JavaFX is to use the NetBeans Platform as your basis. You would not be the first. There is, in fact, a very long list of applications that you can see online from NATO, Northrop Grumman, US Navy, many other organizations in the logistics, defense, aerospace type fields, all kinds of industries really. You see at the top there's different categories that you can take a look at what people are doing with the NetBeans platform. In the financial sector, banks, for example, using the NetBeans platform as the basis of their back office application software. You can also see on this page that there are two kinds of applications, those that are marked with a key and those that are marked with an envelope. And the ones that are marked with an envelope are the ones that are open source. So you can actually take a look at some open source applications and learn from those. For example, there's this integrated breeding field book application created in Mexico. There's an application called AgroSense created in the Netherlands. Very interesting application for managing farms. So there's a whole range of different applications that have been created in this way. What these applications have in common is that they make use of the services provided by the NetBeans platform, which typically in the first place is a Windows system, so a docking framework, detachable windows, toolbar, menu bar, and these all come with it and can be used depending on your needs. So this is what the application that you've seen looks like on the NetBeans platform. It looks exactly as it did before, except that we have now a window system, most clearly, so you can float the windows out of the frame, and they will continue to work exactly as they did before.
Yeah, click on a button too, and you'll see it. You see the other charts change in the other windows too.
Right. Everything continues to be synchronized, despite the fact that this is now undocked from the frame. So these kinds of services are a standard part of the NetBeans platform, and I think is of benefit in the context of JavaFX as well.
Yep, great.
Thank you.
So what you guys want to do probably is to, when you download the code, you want to see the difference between the design of these two programs, right? Because the first demo program was a standalone JavaFX application, and now we've made this even a more interesting UI because we've integrated into the NetBeans platform, which not only has window management, like Geertjan said, but it also has lookup services and a lot of other things as well. So do we need to show them anything else in the program? Yeah, so yeah, that's right. So this is an important thing that we wanted to tell you, and that is that in our experience with working with JavaFX in the NetBeans platform, and we've done a number of different JavaFX applications with this swing-based framework, we discovered that this is really a great way to go for the design, and you could take this approach with other frameworks as well. Recall that a window in the NetBeans platform is called a top component. So what you can do is use this arrangement to separate the JavaFX code from the top component swing code. And what specifically is the top component will instantiate the JFX panel and invoke the FXML loader. And then the FXML loader will read in the FXML, build the JavaFX scene graph, and instantiate the JavaFX controller class. Then the top component will invoke controller public methods to manipulate the scene graph. And this, the squiggly line that we have in between the top component and the JavaFX controller represents the fact that you must do that on the JavaFX application thread. And that way, the controller code does not directly invoke any methods in the top component. We found that this is a really nice way to integrate JavaFX into the NetBeans platform applications and to make everything work correctly. So yeah, let's go back to the program again. And did you want to talk? Did you want to talk a little bit about the organization?
Yeah, I did.
Right. So Gail's just going to take a couple minutes to talk about how this program is organized, since it's designed differently than the standalone program.
Okay, one of the other nice things the NetBeans platform provides for you is that it allows you to break up your huge monolithic program into separate modules that you can maintain separately. And that's exactly what we did with our blood pressure reading monitor program. So we broke it at one single program. We broke up into 6 modules. 2 of them provide services that the other modules use. One is a private implementation module that no one else really accesses but does all the work. And the other one is a model module that has both our BP data module class and any management in which the other modules can access the data. And then the other 4 modules are the separate windows that each have been broken up into separate modules. And so I'm going to go back to the... So each of these 4 windows are separate modules, and we can interact with them before. And everything's the same. And then
sometimes people say, well, yeah, JavaFX is cool, but maybe it's just about spinning circles, right? Well, we couldn't resist the temptation to have in our code here a spinning graph. This is actually super easy to do because animation techniques and rotates like this can be applied to any node in the JavaFX scene graph, right? So all we did here was apply a rotate transition to the parent node of all the scene graph that represents the line chart, and it all is just easy to do. Of course, this has no redeeming value whatsoever, but it is kind of cool to look at. Right? We couldn't resist doing it, but that's it. Okay, so let's go back to the notes now, and we're going to wrap things up. Here is what we did today. We did quite a bit. We talked about the importance of using properties in JavaFX, and we showed you how to use listeners and binding techniques. And we went through the binding strategies to show you that there's a lot of cool things that you can do to make it easier for you to design your UIs and not have to write as much boilerplate code. We also talked about observable lists, sorted lists, and filtered lists, which are also in our demo program, and we're using those in interesting ways that you might want to look out. And we also talked about extractors, which we ended up not needing in the program, but we still felt that we should tell you about because they're important too. And then we showed you how easy it is to do this in Java 8 with lambdas, and also specifically how to use binding techniques with listeners and in streams in Java 8. We also took the demo program that was standalone in JavaFX, re-implemented in the NetBeans Platform to show you how to integrate Swing and JavaFX together. You learned about JFX Panel and the thread issues, and a little bit about how the NetBeans Platform can even make your UIs on the desktop more appealing. Okay, I want to thank everybody for coming. Here are our email and Twitter handles if you want to contact us with any questions. You can go to our website, asgteach.com, and you'll see the Devoxx logo and things on our site there, and then you'll be able to click there and download a zip file. Right now the zip file says Java 1 2015, so don't think that's the wrong one if it's there, because we gave a talk that was similar, a longer talk when we were at Java 1. But it's the same code, and the zip file is all there for you. That'll be the two programs that we went through today, and you can do that. So we're right on the money here at 5 minutes left. So I think we'll take some questions now. And I don't know if we have any, I can't see too well, but I don't know if we have any microphones. But yeah, but if you can yell out, that would be great. And again, we're looking for some interesting questions because we have some books to give away here. So questions?
You guys don't get books if you don't ask a question.
Okay. Yeah.
There.
Is there a plan to use annotations for binding, for avoiding to declaring the same multiplies property?
To use annotations for binding? I think you have to ask Mark Reinhold that, or somebody, Jonathan Giles, somebody at Oracle on the JavaFX side. We're just community people using it.
Yeah, you might be able to do your own annotation processing as that, but we haven't heard of any of that specifically. But Jonathan Giles at Oracle would be the person to contact about that to see if that's on their list or if other people have requested that. Another question?
Yep, up there.
This one here.
Mm-hmm.
What about threading? When you use bindings on listeners, data is updated for you. Is that done in the same thread, or is separate thread?
It's done on the JavaFX application thread. Well, it's done on the thread that it's in. So if that's a good question, if you're using binding, you need to and any of the elements that are in the bind statement refer to nodes on the scene graph, then you must make sure your binding occurs in the JavaFX application thread. So yeah, that is an issue. You can't use a binding with a background task. That would provide problems.
There was another question.
There was another question.
Yeah, you showed us bindings with the factory and with the Fluent API.
Yes.
Is there a difference? Are they interchangeable, or is there something you can do with one and can't do with the other?
Okay, that's a good question. Okay, the Fluent API is a smaller set of library expressions than the binding. In my JavaFX video, I show people how to equivalently do certain things. Like you can use the Fluent API, and here's how you can use the bindings class, and you can do it either way. But the correct answer to your question is there are more binding libraries in the bindings class. So especially with the creationals that I showed you, there's no way to do that in the Fluent API. So the bindings class is larger, and you can do more things with that. But I would say that the Fluent API is easier to use and easier to read, because can you see that if you nest the bindings calls, that they would be nested out in and out, right, with calls that are with parameters that are parts of other ones, whereas the Fluent API reads left to right with the builder pattern, right? So I kind of recommend to people to try and use the Fluent API as much as you can, but there are definitely more binding expressions available in the bindings library. Yes?
When NetBeans will be JavaFX.
It already is partly. The browser inside NetBeans is the JavaFX web view. So the answer is where it makes sense, NetBeans will use JavaFX, and that's one place where it makes sense. But I don't see us rewriting the entire NetBeans user interface to use everything that JavaFX has, just on an as-needed basis.
Okay, we have time for one more question. Yes?
Will the NetBeans GUI builder support JavaFX to create Java code sometime anywhere in the future?
Instead of the FXML.
Instead of the swing code. So now
Yeah,
you
Matisse.
can create a GUI with swing code in Java, but not with JavaFX.
There's a couple of different plugins that you can install that do the same thing. So it's not the native Matisse GUI builder, but it's a couple of plugins that provide that exact same functionality. So given how many different things we want to work on, and you look at the fact that there are at least 2 plugins that already provide their own builder, it's not going to be a very high priority, I think.
Well, and also Scene Builder, which we didn't show you,
yeah.
but we used to build this application, is a drag and drop, but it's standalone. But you can, from the NetBeans IDE, you can double click on your FXML and Scene Builder comes up. So even though it's not directly integrated into NetBeans, they did this so it can be used from any of the IDEs, and it's Gluon supports it, and it's very good.
Yeah, and there's actually a couple of plugins that provide integration of Scene Builder directly into NetBeans. So that's an external tool does not open up, but it happens within NetBeans. So that's basically the support provided by the community for that.
And we really do recommend the concept of using FXML because it helps you separate the view from your logic controller model and controller class.
Okay, so looks like time is up. I like the question about the Fluent API and the bindings class. So if you come on down, we'll give you an autographed copy of our book. And
I like the question about the Matisse GUI builder and Scene Builder and so on. You can win the NetBeans IDE beginning book.
okay, so thanks a lot for
Thank
coming and have fun with JavaFX.